I have an easy proof of minus 1 by 2 factorial that does not involve Gaussian integral. So basically, most of the proof that uh, gamma of 1 by 2 is root pi involve the Gaussian integral from 0 to infinity of e to the power minus x squared dx. But in this video, I will prove this statement without using Gaussian integral. And now, if you know about gamma functions, you obviously know that gamma of n is n minus 1 factorial. So that's why I'm writing gamma 1 by 2 over here, yeah, power of minus 1 by 2 factorial, yeah. Now, the proof starts with a beta function, yeah, and we will make some manipulations and surprisingly get this result. Let's see how. So basically, beta function is integral from 0 to 1 t to the power m minus 1 1 minus t to the power n minus 1 dt. This is the beta function of m and n. Yeah. Now, we will make a substitution. We will make a substitution that x is t to the power m. Yeah. And then our dx will be t. Yeah. Okay. It will be m times t to the power m minus 1 dt. And then dx by m is equals to t to the power m minus 1 dt. Okay, so now we will make this substitution. Now integral will go from 0 to the power 1, m is 0 and 1 to the power m is 1 itself, and over here t to the power m minus 1 and dt will make dx by m, and we have 1 minus t is x to the power 1 by m to the power n minus 1, and this is beta of mn. And bingo, we got a new definition for beta function, and this will help us solve the problem. Yeah. Okay, so basically, let me also draw this. Yeah, fine. Now after this, now if we substitute m is equals to 1 by 2 and n is equals to 3 by 2, you will see something. Yeah. And let me show you what will you see. 1 minus x and 1 by m, 1 by 2, that's just 2, and 3 by 2 minus 1 is 1 by 2 dx, and m goes to other side, yeah, and m is 1 by 2, and beta of m and n is just gamma n by gamma m plus n. So gamma m and then gamma n by gamma of m plus n is 4 by 2 is 2. Yeah, fine. Yeah. Okay, so if you don't know about that, let me write it over here, the formula. Gamma m, gamma n by gamma m plus n. Okay, so now this is a well-known like equation. This is just root under 1 minus x squared dx. Yeah. Now many of you might know that y equals to root under 1 minus x squared is just the equation of circle, because if you just square both sides, you will get y square equals to 1 minus x square, and then y square plus x square equals to 1. This is just the equation of circle. Yeah. And because here is a plus sign, we will have equation of circle in just the positive axis. So basically it will be like this. Yeah, this equation. And we will have a 1 over here, we will have a minus 1 over here, and so this equation represents this semicircle, yeah, going from minus 1 to 1. And now we have to integrate from 0 to 1. So this is the area that we want, yeah, for this integral, and we know that that's just like pi r square by 4, and r is 1 over here, so that's pi times 1 square by 4. That's just pi by 4. Yeah. So we know the area over here. This is just pi by 4. And from the other side, we get 1 by 2 times gamma 1 by 2. And gamma 3 by 2 is also 1 by 2 times gamma 1 by 2. And gamma 2 is just 1 factorial, so that's 1. Now we can cancel the 4 in the denominator with the 4. And now you see, our gamma of 1 by 2 whole square is pi. So, and what does that imply? That implies gamma of 1 by 2 is root pi. So this is a beautiful derivation of the gamma 1 by 2 value, yeah, using beta function, and using just the fact that the area of circle is pi r square, nothing more than that, nothing more than that, like you going to Gaussian integral and then using uh, polar coordinates, yeah, nothing of such stuffs. And this was in fact a beautiful proof, yeah. And now gamma 1 by 2 is just minus 1 by 2 factorial, and so that leads us to the statement that I made in the beginning of this video. Hope you enjoyed the proof. Thanks for watching and look forward to seeing you in the upcoming videos too.